Hi guys, welcome to another video. So in this video, we are going to be discussing about one of the many ways that we can actually secure our Flutter app. Of course, we are not new to it that Android devices can be rooted and iOS devices can be jailbroken. If your app is running on a jailbroken or rooted device, right, what it would mean is that attackers can have different ways to bypass security features to get access to sensitive information in your app. For example, your app could be susceptible to man-in-the-middle attacks, and even quite a number of the platform-specific features that actually come with the phone, right, would be disabled by default because it's a jailbroken or rooted device. So what it would mean is that all of the data that you stored locally could actually be visible to an attacker, and then it would mean that an attacker can actually start logging keystrokes from your app to be able to, get access to information from your app. So today we are going to be building this Flutter app that displays this dialog to any user that their device is unsupported. That is, if the app is running on a rooted or a jailbroken device. Without further ado, guys, let's get right into it. Welcome back. So we have our template app here, which is supposed to simulate a real world app where you have like a login screen. We want to ensure that our security checks happen even before a user gets to this kind of screen where they are able to enter sensitive information. So to be able to check if the device is jailbroken or rooted, right, we're going to be making use of this package on pub.dev called jailbreak root detection. By the way, you can decide not to use a package, right, and then decide to write your own implementation by yourself if you know how to make use of method channel to actually call code on the native side into your Flutter app, right? So, and if you take a look at the description, you will see that it says uses root beer plus detect reader for Android and iOS security suite for iOS jailbreak detection. We're going to just grab this jailbreak root detection, right? And then go straight to our pubspec.yaml file, right? And then just add it there. So we're going to come straight to our dependencies, paste this here, and then press Ctrl S to run get, right? And then after we have done this, so also to note, aside from this login screen, which is a template one, we have also created something called a compromised device modal here, right? So this is the dialog that shows up when the app notices that, okay, this phone is actually a rooted phone or a jailbroken device, right? And then we have our login file here, which is what we can see on our screen. Then we have our main.dat here. Then this is the auth API resource, which is just supposed to simulate that you are making a network request basically. So, but we will not be making use of that. So next thing we're going to be doing is that we're going to be creating another folder called security, right? And then we're also going to be creating a file called device integrity checker, right? This file is going to have a class called device integrity checker. I mean, you can see that we're getting suggestions from GPT, but we will not be making use of method channels today. We're just going to be making use of that package. Next thing we're going to do is that we're going to create a feature of bool, right? Sorry, this is supposed to be const, not class. A feature of type bool called is device compromised, right? And then it's going to be an async function. And then we're going to wrap this in a try and catch. So in case anything happens on the native side, right, or something just happens, in flight while we're trying to make our checks, right, we're going to return false. Then here, we're now going to say that final is compromised equals to awaits future .any. Now, the reason why we're using future.any here is that it is possible that maybe somehow the jailbreak root detection package just decides not to return any response on time from the native side. Maybe something happened on the thread while this is being called, right? And we don't want our users getting stuck. So we're wrapping this in a future.any. What happens pretty much is that if we have two futures in this future.any, whichever one returns a result first is what the framework picks, and then it moves on. So the first thing we're going to do here now is that call jailbreak detection dot instance, right, dot is not trust. So it means that if you take a look at this is not trust now, you will notice that it says if it is jailbroken, if it's a real device. So if it's on Android, it checks if it is jailbroken, or if it is not a real device, or if it is on external storage. And then for iOS, in this case, now it will check if it is jailbroken or if it is not a real device. So if it's a jailbroken device or if it's not a real device, then it returns true for us that it is not a trusted device, right? Now, if it now happens that this does not return a response on time, then we're now going to add a future.delete here, right? and then just set it to 5 seconds so that if anything does not happen within 5 seconds, our app proceeds so that our users do not get stuck on a screen just waiting for something to happen, right? Then we'll now return it's compromised here. Then the next thing we're going to do now is that we're going to create a widget here in our widgets folder called app security gate.dart. Then we're going to create a stateful widget here called app security gate. And then we're also going to take in, the integrity checker. So we'll say final device integrity checker, right? And then we're going to import this. So now we're going to be making a check now to see if our device is compromised or not, right? So I'm going to be creating a feature here of type bool, right? And then I'll call this integrity feature check, right? And then let me just remove this off, make this nullable, right? And then we're now going to say feature of type bool resolve integrity, and we're going to wrap this in a try catch. We're just going to create a boolean here called is compromised, and then we'll set it to false. So we're going to remove this file now. Then this is also going to be here equals to false. Then we're going to return is compromised. So before we return is compromised, if mounted, right, and is compromised, then widgets binding dot instance dot add post frame callback. And this is because we want to ensure that the first frame has been drawn already before our app attempts to launch our dialog to then show to the user in this case that, oh, this device is compromised. So now we're going to call a function here called show compromised dialog, since we're using a dialog, right? And then I will now create another function called show compromise dialog. We're also going to need to have something here called a shown dialog, so that we're able to control if our dialog has been shown already or not, so that we don't keep showing the dialog to the user over and over again. We're now going to say that if dialog has been shown, right, if as shown dialog, or if it's not mounted, then we need to return here so that nothing happens. Then we're now going to set our shown dialog to be equal to true. Then the next thing we're going to do is to await show dialog, and we're going to mark this async. We're just going to remove this now that was created by the AI auto completion, and we are now going to return a pop scope, and then we're going to set can pop. We're going to set it to false. And this is because we do not want the user to be able to pop this dialog off once we have shown it to them, right? Then we're now going to set the child to be our compromised device dialog here, the one that we have in this case. So let me just rename this to compromised device dialog, not to modal, right? Let me also rename this compromised device dialog, right? So then we're going to rename, right? And we're now going to say it is compromised device dialog, right? So let me just remove this off. Then let me import the file, and then on close app, this dialog was generated by an AI tool anyway, so I don't know why it's added on close app there, but yeah. Now the next thing we're now going to do now is that we're going to show compromise dialog here. Then we're going to call our init states now. Then we're going to instantiate our integrity feature check here now. So the next thing we're going to do now is that we're going to come into our widget here now and create a feature builder. Let me just use autocomplete. So pretty much we're going to create a feature builder and then assign our integrity feature check here to it, right? And then of course do our checks. If connection state is loading, we show you an empty screen, right? And if the device is compromised as well, we show an empty screen, because do not forget, when our device is compromised here, we're already showing a dialog. So the dialog is going to be overlaying on this screen. So there's pretty much no reason why we should be showing anything if it is, if the device is compromised. And if it is not compromised, then we will now show our widget in this case, right? So the next thing we're now going to do is that we're going to go back to our main screen, right? Then we're going to wrap our login screen, right, with our app security kit, and we're just going to stop and rerun because we added a package, right? Okay, guys, now that our code is running, we can then see. So by default, right, remember, if we take a look at the source code of the device integrity checker, right, let us check here. It is seeing here, right, if it is not a real device, right, or if it is jailbroken. And by default, right, an iOS simulator is not a real device. So because of this, we can see that this pretty much comes up and then says unsupported device security state. This device appears to be a jailbroken or rooted device, right? Or for your protection, this app is blocked on devices that do not meet our security requirements. And then because of this, we would see that even while I'm clicking outside of the dialog, this does not pop off, and then the user is not able to use the app. So yeah, pretty much, guys, this is one of the few ways that you can secure your app and then ensure that attackers do not try to use jailbroken or rooted devices to maliciously get access to sensitive data, right? So that is going to be all for today, guys, and I'm going to see you guys in our next video. Please do not forget to like, share, and then subscribe to my YouTube channel. Peace.